Hi guys and welcome to yet another Devcast. Today I'm going to talk about an update to the Progen, which is a procedural generator for Unity. And it will be about the two new processors that I added, and it's about the room and passage generation. So let's quickly jump right into it. First, there is the room processor, so you can standardly add it as a room processor. So it is for room generation, obviously. So there are a lot of stuff that you can actually customize. So let's start. Currently, I have just a simple room. There is one count with a minimum size of 5 in both directions and maximum size of 20. It's not so exciting. So let's start with it. Let's say we want to generate 5 rooms. We also can generate secondary rectangles. So these rooms can have these custom additional rectangles to them, which generates a more roomy outputs. We can also set up collapse, so it will collapse these rooms together by a value. So it's more for a game layout, for example, what we want, than without the collapsing. It will basically try to collapse the rectangles into the middle till they can collapse, obviously, because they will never overlap. So let's say we want the collapse. We can also we can also specify the value for the room, the output value. So let's say we can also specify that we want a different value for walls. So now we generate some walls as well. We can also generate doors with a specific value. You can have doors even if you don't generate a specific value for walls if you want to, but it is useful for various additional generation on top of it. So you can, for example, have a star that walks through room and doors, but not through walls, and so on. We can also additionally specify a layer where we want to output this, but we will just go straight directly to the output. This is something that I added to previous version that I didn't do a Devcast about, is that you can specify this processor. It goes only to a specific layer, something like a Photoshop layer, and it doesn't generate an output to a final generator. For example, I will show you in the next processor, because this is pretty much what we can do with the room processor. Let's say I don't really want that much of a collapse, or let's go. Uh, I will greatly appreciate if you send me a feedback on an additional things that you would like to see in this room processor. Something that you want, for example, like, okay, this or everything on the right should collapse but nothing on the left, and so on. All these use cases that are not really that straightforward but would be useful for you. So let me know and I will think and how to implement it in a feasible manner. So that's the room processor. I will add it. I will leave it here as an active. Let's jump to, before we go to the passage processor, let's jump to the preview I mentioned that I want to explain a bit. Let's see that this is a room. Okay, so now you see that the preview can now preview the output. This is the none, means that it is the final output, and then you can preview at different different layers as well. But this layer is since we have room processor, the only processor here, so the room layer will be the same as the output. That's one new feature. And another new feature in the latest version is the color map. It's if you want to specifically preview a value with a different color. So let's say that we have a room value, which is the 255, then there we have wall value, which is 200, and then we have door value, which is 20. But These are values for our generator, but we, for example, want a different visual representation for our preview. So we can say that we want the 0. As you can see, we want the 0 value as a red one. So everything that's 0 will be red and will be pop right to us. For example, we want the doors to be, so it's a value 20. We want the doors to be 20, and we want the walls, which is 200. We want them to be green, and so on. So this is just for a preview, and you can visualize, if you have a complex procedural output, different values using different colors. So that's all for the preview, and now jump right into passage processor. So let's go, and we want the passage processor. So again, we need to specify what's the input. So the input for us, so where the passage will look for start and end points. And we need to specify the input value. So our start and end points will be these doors. So which is a value 20, and the input is uh, current current output, because the room processor is directly above the passage processor, and we see this one, so we can use this. We can also use the room layer if we wanted to. So the 20, and we want the one passage count, and we can try okay, we need to specify a passage value, what's the value that will be used for the passages. Let's say we want like 208, and we don't want a constant layer, so we can specify. Okay, so as you can see now, it generates one passage from this door to this door. If we generate a lot of them, you can see that it generates something like this. This means that it actually connected the room to itself. Which is, if you don't want that, you need to specify connect unique. This is especially useful if you want to generate from a lot of points, or for example you have other processors that generate a pattern, for example the conv chain processor in our case, and there are islands in the pattern, and you want to connect only unique islands, so it doesn't connect, because you can have a huge island here and a small island here, and if you don't specify connect unique, there is a lot of points on the huge islands that can be connected to themselves, because you can have passage outside of the island, and it will connect the island to itself. It's pretty feasible output that you may want, but if you want to specify that you want only unique islands, which is this one, I will probably work on the naming. You need to click that you want to connect only unique islands, and it will connect only that. You can also, as you can see, you can also specify the constraint. This is the constraint that, because let me show you something. I will not collapse it. If I generate these passages, it's pretty straightforward generation, because it goes to the minimum, to the best feasible way, the easiest way to go there, or one of them. There could be many the easiest ways. But if you want to specify some kind of like randomization here, you can use constraint type with a different value. So let me show you. For example, I can add Perlin. So this is a Perlin. We go, for example, up here, and let's add. This is a Perlin layer. Let's preview it. So this is our Perlin layer. We want higher, so it's more noisy. So this is our Perlin that we just generated, and we can now use this layer to randomize. We don't want the Perlin in the output. We can use this layer to randomize Okay, there was one bug that I just fixed. Now you can, as you can see, now since we have a constraint based on the Perlin, which is here, it uses the Perlin noise values for A star. So it goes in a non-direction, non-linear way through the mazes. All these have different weights in the A star algorithm. So it generates these more randomized passages. You can also specify more passages between the rooms. Okay, let's do some kind of collapse, and this is the way to generate various room layouts with connecting connecting passages. Again, I would like to hear any feedback, or you can write to me about this passage processor. There are a few things that I want to add as well to make it more readable as for the values, but currently we need to focus on this as fast as possible because we are actually using it. So, but if you want something that covers a specific use case, I can add it to my to-do list and based on priorities, because priorities are ours, but you can come up with a specific use case that would be very useful for us as well. So I welcome any kind of feedback, and I hope it helps you in generating these layouts that can then be used to, for example, the wave function collapse and so on, as we use it, or a different, on in any different way. So that's all for today, and thank you for watching.